Today we're going to learn how to do portfolio analysis to be precise performance and risk analysis using a package called PyFolio in Python. This video is going to be primarily interesting to those of you who are finance people interested in a little bit of tech, but also for those of you who are tech people interested in a little bit of finance. If you like this video, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so we're going to do portfolio analysis, specifically risk and performance analysis in Python today. And for this, I'm going to start right away with the environment setup. I'm going to move to my working directory. In my case, it's called tutorial. And here I'm going to set up a new environment. Now, if you don't know a lot about Python, if you just have it installed and you maybe know how to install packages and how to use stuff, the easiest way to install the packages we're going to need in this video today is to use pip directly, pip or pip3 install, and then the packages that we're going to need in this video today. I'm going to say in a second which packages those are, but in my case, since I like to use isolated environments, I'm going to use UV. If you don't want to use UV, if you don't know what UV is, don't be confused by that. It's the exact same result, just that you're using a different Python installation than me. So in my case, I'm going to say UV init. If you want to use it as well, you can also do UV init, and I'm going to say UV add, but you can, as I said, say pip or pip3 install instead. But in my case, UV add, but you type the exact same package names. First of all, we're going to need yfinance. Yfinance is what we're going to use to get the financial data, stock information, specifically stock prices. So yfinance is that package for the Yahoo Finance API. And then we're going to need PyFolio. However, PyFolio is no longer maintained, and because of that, we need to actually use a fork of PyFolio called PyFolio-Reloaded, which is maintained by a person who also writes books, as far as I know, about algorithmic trading. He maintains a couple of these financial packages, and this is now the new version of PyFolio, basically. In addition to that, we're also going to install Jupyter Lab so that we have an interactive Python notebook environment that we can work in. And as I said, either UV add all of this or pip install all of this. Once you have this, you can go and start an instance of Jupyter Lab. So either you do that by just typing Jupyter Lab like this, or if you're also using UV, you say UV run Jupyter Lab. What this will do is it will open up Jupyter Lab in your browser. So you will open an environment like this here. You can get rid of the main py file if you're using UV. This is automatically generated. And in here now, in this Jupyter Lab environment, and maybe you have a different theme, maybe it's light themed and all that. But what you want to do is you want to click on this plus and you want to create a new Python notebook. So that is what we're going to be working with. For those of you who've never worked with interactive Python notebooks, the idea here is that we have individual cells that we can execute. So I can do some Python stuff here, a equals 10, then I can start a new cell and I can say print a, then I can go up again, I can say a is now 11, I can print again. I don't have to run the entire script every time from scratch, but I can just run individual cells, which makes sense because sometimes loading data and doing calculations takes some time, and then I just want to do some small adjustments afterwards, and I don't want to load the entire data set and pre-process it or calculate stuff again. So the code in this video today is going to be quite straightforward and simple. It's a very beginner-friendly tutorial, so it's perfect for finance people getting a little bit in touch with Python, so trying to learn a little bit about Python, but also for Python developers, programmers, tech people that want to learn a little bit about finance. This is a very simple and straightforward tutorial. So we're going to start here by importing the two packages that we need. First of all, PyFolio as pf, and then also yfinance as yf. And by doing that now, we have access to the Yahoo Finance API, so we can just download information in stock data for a specific ticker symbol. So I can say here data is equal to yf.ticker, and then I can choose a stock that I'm interested in. Let's say, for example, Goldman Sachs, GS. And I can take from Goldman Sachs now the history by calling the history function, and I can specify the time frame, which in my case is going to be max, and this means just take the entire time frame that's available. So if I do that, I can take a look at this data frame. This is a pandas data frame. If you don't know what pandas is, you can maybe watch my crash course on pandas if you're interested in that. Otherwise, just accept that this is data that you can work with. And for every single timestamp here, so for every single day, essentially, you have open, high, low, close values. For those of you who don't know what that means, it basically means the stock market opens at a certain time, closes at a certain time. That is the opening price. That is the closing price. And in between, you have a high, the maximum value reached on this day. and the lowest value reached on this day. And everything in between is some volatility that you can take a look at. Volume is basically the amount of shares that changed hands. And the interesting thing for us, since we're just analyzing the performance and the risk of our portfolio, is we're going to take a look at the close value and we're going to calculate the returns for a very basic buy and hold strategy. So how do we do that? We can do that by just calculating the returns as follows. We can say returns is equal to data close PCT underscore change. And what this is going to do is it's going to just take the change for every day compared to the previous day. So if I just take a look at returns now, this is going to, of course, be not a number for the first day because we don't have a previous day to compare to. But from this point onward, we're going to have the percentage change. How much more or less is the stock worth now compared to the day before? And if we accumulate that, so if you actually aggregate this, you're going to see that this is the buy and hold return. So if I buy on the 4th of May, 1999, and I sell today, that is going to be the cumulated or cumulative gains or changes. And now there's only one more thing we want to do here before we start with the actual analysis of the portfolio, which is we want to define a benchmark. So something to evaluate against. It's not necessary to do that. You can also just evaluate and analyze the returns themselves, but it's also interesting to compare it to some baseline, some benchmark to the market, so to say. Usually people go with the S&P 500 when trading stocks. So the goal is to outperform the American market, which is usually indicated by the S&P 500. So what you can do is you can say bench is equal to Y Finance ticker, and then we can provide the ticker of the SPY. So that is the S&P 500 index, history, max as well. And of course you can pick any other benchmark. You can also go with the Apple stock, for example, if you want to. But of course it's not Y Finance, it's YF. And this now is the exact same thing as for Goldman Sachs, but now what we're going to do is we're going to also go bench returns, and we're going to say bench.close percentage change to get the percentage change here as well. And now we need to align them because the problem is that these don't have the same date range. This starts in 1993, this starts in 1999. So we need to actually make sure that we can align those, and we can do that with the align function. So since these are pandas data frames, we can just say returns, bench returns is equal to returns align, bench returns, and then join is going to be inner. So only if both dates are present in both data sets, we will get this. We can also do a drop NA. So maybe let's do that. Returns is equal to returns drop NA to drop the NaN values. Same with bench returns here. But besides that, or actually maybe we should do that before. So let's maybe do it like this. Drop NA, then returns. And now they should have the same time frame. So if I look at bench returns and returns, we're looking at the same dates, and we can compare the performance. Now you might be thinking that the portfolio analysis is the difficult part, but actually this was the difficult part. This is actually all you need to do in terms of pre-processing. You need to prepare some returns. Now, one caveat here, this is important. If you want to use another strategy, not a simple buy and hold strategy, if you have an algorithm that you're evaluating, if your portfolio actually has different returns because you have certain decisions that you make when certain events happen, then you need to make sure your returns actually show what your portfolio is doing. So you actually want to see the performance of your portfolio, the returns of your portfolio, not just accumulating all the percentages of the individual assets if that's not what you're doing, if you're not buying and holding. But once you have all this, all you need to do is you need to call from PyFolio pf.create and then returns tear sheet. And there's also other functions that I'm not going to cover today, but as you can see, there's a bunch of tear sheets that you can create. We're going to take a look at the returns tear sheet, and we're going to pass here now returns. Then important, we need to pass a live start date. The idea is we have a period for back testing and we have a period where we actually start trading. So in your actual financial scenario, that would be the day you start actually applying your strategy, actually going and investing money into your portfolio. And this is where you want to start evaluating the actual performance, not just back testing. So this could be something like 2023 1st of January. Now, one thing here before we move into more explanations, I need to mention this for the sake of transparency. I am not a financial professional. I'm a tech guy. I'm a programmer. I'm a machine learning engineer. I'm a computer scientist. I'm nobody who understands finance deeply. So if I say anything about any metric, about anything in finance here that's not correct, please, forgive me for that, because I'm not really an expert in that field. So also, this is not financial advice. This is programming advice. I'm just showing you how to use a package to do some interesting stuff. But of course, you need to know what you're doing here. So we're providing the bench returns here as well. So we have returns, live start date, and benchmark returns. And now running this function gives us everything we need. So what we get as a result of calling this function is, first of all, a table with a bunch of data that we're going to talk about here in a second. And if we wait a little bit longer, we're going to get a bunch of plots. You can see we get a lot of visualizations here. And we're going to talk about these as well. So from now on, this is basically the programming part. If you're a finance guy and you know exactly what you're doing here, you understand all of these numbers, you understand these plots, you don't need me anymore. You can stop the video. You can just go and use it. You can also try the other functions. For those of you who are programmers and want to learn a little bit about finance, at least to the degree that I can understand what is happening here, I'm going to briefly cover what this package gives us here, and we're going to see why this can be useful. So what does the output actually show us? First of all, the start date. This is the absolute start date. So that is actually the first date that is available in the data set, and the end date is today, or actually the last trading day. So the 7th of January. Then we also see how many months are in sample and how many months are out sample. In sample and out sample means the time periods that are backtesting and the time periods that are actually live. So live is the in sample in sample is the backtesting, and out of sample is the live data. And this is also the same here. We have the in sample, out sample, and all. So maybe we can use a graph down below to explain this. We have this graph here. I'm going to explain what it shows in a second. But this time period here, from the very beginning up until to our start date, that is the in sample data. This is for backtesting. And then we have this time period here from 2023 going on. That is the out of sample. And the entire thing is all. So we have in sample, out of sample, all. And all just is both of these in one. And now we have a bunch of numbers that we can take a look at. We have the annual return. We have the cumulative return. The idea is that you have the cumulative returns as a basis. So that is how much money did you made over this time period. And the annual return is just considering that if you consider the geometric series in reverse. So maybe I can open up a calculator here. I can open up Python. If we know that we made this amount, we can also go back to this amount, or the other way around. If we know that we make 43% per year, that does not mean that this is just this divided by the time frame, because we're having actually a geometric series, an exponential growth. This is not just having this summed up. We actually need to do the multiplication. So think about it this way. If I have some asset that performs like this, so it gives me 43.499% per year, and I do this for 3 years, what this means is that I have 1.43499 to the power of 3, and then, actually, this is not how you do it in Python, to the power of 3, and that whole thing minus 1. So that would be 195,195. This is exactly what we get here. So this is just the overall return that we get over the time period. So if I did buy and hold for 3 years, that is the percentage. So if I started with $1,000 and I applied this, I would have gotten 1.95491. So times that would be the money that I have in the account right now. And if I want to know what this means per year, this is the annual return. So that is how much I earn per year in this time period. In this time period here, which is much longer, it's 8% on average. And if it's the entire time frame, it's 11. And you can also compare that now to the S&P 500, which we can see in the graphs below. But that is the basic idea. You have the cumulative returns, which is the entire return that we get at the end of the time. So I invested a certain amount times this percentage is what I get at the end of the time frame, and the annual return is just that considered on a year-by-year basis. Annual volatility is just how much the price jumps around. It's a calculation with the standard deviation, the square root of 252, which is the number of trading days. but basically this just means if I take a look at a 1-year time period, how much percent does the price jump around? That is what the annual volatility tells us. And then we have a bunch of ratios that are finance ratios. We have Sharpe, Kalmar, Omega, Sortino, and tail ratio and stuff like this. And I'm going to try to briefly explain them. I have some notes here on my second screen. For those of you who are interested, I can briefly summarize this. So the Sharpe ratio basically tells us how good our returns are compared to the risk we took or compared to the volatility. A Sharpe ratio above 1 is considered to be good, below 1 is considered to be bad or not so good. And basically the idea is you can make good returns, but if the risk is crazy, then your returns are not as good anymore. So a Sharpe ratio above 1 is considered pretty solid, pretty good, and below 1 is not so good. The Kalmar ratio tells us how good our returns are considering the worst drop that we had to endure. So down below, there's also a graph showing this. We have some periods where we actually have pretty solid drops in the price, and it takes quite some time to recover these drops. And the question now is, what do our returns look like considering that we had pretty rough periods that we had to survive, and this is expressed in the Kalmar ratio. The stability, as the name already says, tells us how stable the price is over time. It basically tells us how explainable the data is by a line, so how easily we can fit a linear regression model. Basically, this is the R-squared score of a linear regression model on the data. So if the data doesn't jump around a lot, a line is almost going to fit it perfectly, which would be close to 1. And if it's very crazy, it's going to be close to 0. So that is basically the R-squared score of a linear model. The idea being that if I can explain this segment here by a line, which I probably can pretty well, then it's going to be closer to 1. If it's very, very crazy all the time, then it's going to be hard to fit a line with a decent score. Then the max drawdown basically tells us the worst drop that we had. So considering that we have a certain max value, a certain high value, how much did we drop immediately afterwards before reaching the next high? That is the max drawdown. So if you have something like, where's the graph? If I have something like this here, that would be a high. And then the worst drop that I experience from this high until I get to another high again. So that is the drawdown, and the worst drawdown is the largest percentage that we fell from a high point. That's the basic idea. The omega ratio tells us how many good days we had versus bad days, also considering how good the days are. So we don't just count good days versus bad days, but we also count how good the days are. So maybe we have a massively good day and then just a slightly bad day. Then of course the massively good day is considered more, and good and bad is defined by a threshold, usually 0. So everything where you gain, you consider a good day, a positive day. Everything where you lose, you consider a negative day. But you can of course also tweak the threshold. For example, maybe everything that is below 0.5% of a gain, you also consider a bad day. That's up to you, but this is what the omega ratio expresses. Then the Sortino ratio is basically like the Sharpe ratio, but we don't punish volatility in general. We only punish downward volatility, so we don't consider it to be risky if the price radically rises all the time. We're only considering downward volatility to be negative. So in the denominator, we only have the downward volatility, which means that we can have a better Sortino ratio than a Sharpe ratio if our volatility is mainly positive. Then we have the skew, a skew above 0. So a positive skew means that we have larger upwards moves and smaller, more frequent downward moves. And if the skew is negative, it's the other way around. We have very steep losses, and then we have smaller, more frequent upward moves. This is just what this number indicates, and 0 is kind of basically equal for the most part. That is the idea of the skew. Then we also have kurtosis. This is basically telling us how fat-tailed our returns are. Essentially, a number that is higher means that we have more crazy jumps, if you want to call it that, and a number closer to 0 would mean that we have more ordinary price moves over time. The tail ratio is also interesting because it tells us how large our largest positive moves are compared to the largest negative moves. So we take the top 5% and the bottom 5% of price moves, and we compare the size, the magnitude of these moves, and a tail ratio that is above 1 basically tells us that our positive moves outsize, if you want to call it that, are larger than the negative moves, and everything below 1 tells us the opposite. Then the daily value at risk tells us that everything below this, so a day where you lose more than that, should be very rare and unusual. This is how I interpret it. Maybe I'm wrong about this. And then we also have alpha and beta, which are only available if you provide a benchmark. Beta tells us basically if our asset is more or less volatile than the benchmark, than the S&P 500 in our case. Everything above 1 means it's more volatile. Everything below 1 means it's less volatile. And if it goes below 0, which is quite rare, it's the opposite. So it moves in the opposite direction, which would be useful for a hedge, for example. But for the most part, that is going to be 1 or a little bit above or below 1. And alpha basically tells us if this asset is outperforming the benchmark, also considering the risk. So in this case, everything above 0 would mean it's outperforming the S&P 500, also taking risk into account, not just the raw returns. And in this case, it's slightly doing that. And then the last thing in the table is the drawdown periods. We have the 5 worst drawdown periods. We see the percentage of the drawdown, which is from the highest point to the lowest point. We see also the peak date, which is the date that the drawdown starts. So the beginning, the highest date. Then we see when does it reach the minimum, which is the lowest point. And then you have the recovery date where you go back to the peak again and you're back in the game. You're back where you started at the peak date. And then you see how long this period was. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. So that's enough for the data. Let us take a look at the charts. The first chart is quite easily explained. It's just the cumulative returns over time. You can see we start here, we end here, and over time we get some returns. And at some point, we start actually evaluating our strategy. What you see here, the blue shades are typical expected paths, so to say, that the price can take. The dark blue is the most likely one, the most typical one. And then you have also some lighter ones that are still expected, still plausible and typical, but you can also go outside of this. And I think the meta stock does this. I'm not sure. Maybe we can check it out later. But basically, you can also just have a price going like this, or also going below the shaded area. And in the background, in the gray color, you can also see the benchmark for comparison. Then we have the same thing here, but the volatility is matched to that of the benchmark. So we adjust the actual asset that we're looking at so that the volatility of this asset, everything else stays the same, is matched to that of the benchmark. And then we can see what this would look like. So in this case, it's not too different. That's fine. Then we can also take a look at the returns on a logarithmic scale. So this is essentially if the price movement is exponential. Here it's going to be a line. So this is pretty linear, I would say, indicating exponential growth. Then the next chart shows the actual returns. Now, green doesn't mean gain in this case. Green just means that this is the in sample. So this is actually the back testing period. And the red means it's the out of sample. So it's the actual live period. But you can see sometimes it's positive, sometimes negative, just the raw returns on the individual days. Here we have some pretty steep gains and losses, which is in the financial crisis. So I guess that's the reason. Then we have the rolling portfolio beta. So is the portfolio outperforming the benchmark, the S&P 500? We can see that the one here is the yes and no line. So yes, outperforming, no, not outperforming. Then you have the average over time. So that is just a line, the 6-month average. And then you have the 12-month and the 6-month moving average here. So you have the rolling average over time, and you can see that most of the time it's outperforming the S&P 500. By the way, here the S&P 500 is not the gray line. This is the 12-month rolling portfolio beta. But you can see most of the time we're above this line that tells us that we're outperforming the S&P 500. Down below, we have the rolling volatility. Not too much to say about this. It's just the volatility of the asset, the volatility of the benchmark, and then the average volatility over time. You can see that the volatility of the asset is basically at all times above that of the S&P 500. It's a more volatile asset than the entire index. Then we can also see the Sharpe ratio. Remember, the Sharpe ratio is the returns, but also taking into account the risk that we're taking, the volatility. And here we have the average Sharpe ratio, and here we have the zero line, the baseline here, and you can see how this ratio moves over time when we consider 6 month as the window. Then in my opinion, one of the most interesting charts here is the top 5 drawdown periods. Here you can see for an asset actually when it starts losing and how long it takes to recover. So here you can see this asset in 2008 had a peak, then it dropped, and until it recovered to go back to where it was in the beginning here, it needed almost 10 years. So I think this is probably 2017 or something. So 8-9 years until we can get from this point here back to where we were. And meanwhile, inflation is eating up the money. So that's probably not a good period to buy and hold here retrospectively. But you can see that we always have these drawdown periods where we have a high, we drop, and then at some point we go back to the previous peak and even beyond that. Then down below we have the underwater plot only showing the drawdown. So whenever we get to a peak and we go down from that peak, we can see this movement in this plot. Then we have here the monthly returns as a heat map. So here you can see the month, here you can see the year, and then every cell is what the percentage gain was in this specific time period. So you can see in some months we had negative 28%. In some months we had 31% gains. So you can take a look at that. Annual returns is here also the same thing per year. So on the y-axis, you have the year, and then here you can see positive and negative returns, and also the average over time. And then the distribution of monthly returns, we can see that there's a skew to the right. We have more positive returns than negative returns. Makes sense, of course. And also the tail is longer in this direction. So we go to more extreme values here to the right than to the left. That is also interesting to look at. And then finally, we have box plots here. So return quantiles, daily, weekly, monthly. What is typical here? What are typical values? What are the outliers? So the best week that ever existed is 0.5. I think this is not percentage, right? This is not 50%. Actually, it is 50%. Yeah, this is almost 50% gain, if I read this correctly. That 1 week had, but overall it's pretty close to 0. For the month, it's pretty close to 0 point something, which is probably 3% or something like this. And yeah, that is basically what we get from this. Now, what I also want to show you is not just what we get here. I also want to show you how you can actually use this to model the entire portfolio. So actually, it was not entirely correct when I said that the people that are only interested in the programming part can skip, because now we're going to model something else. We're not just interested in one stock like Goldman Sachs. We're interested in a portfolio. We're going to keep it simple without too much fancy stuff and strategies. We're just going to have a portfolio that contains 3 stocks, and we want to evaluate the performance of this portfolio with these 3 stocks over time. Now, in order to accomplish that, we're going to start by importing pandas as PD, because we're going to use the pandas series here. I'm going to define a list of tickers that I'm interested in. So these are the assets in my portfolio. Let's say I have NVIDIA, let's say I have Goldman Sachs, and let's say I have Microsoft as well. And now I can also define the proportions. So how much of my portfolio is NVIDIA versus Goldman Sachs versus Microsoft. And I can do that by saying weights is equal to PD series. And then I can say I'm going to have the weights 0.4%. Or actually 40% is going to be NVIDIA, 40% is going to be Goldman Sachs, and then 20% is going to be Microsoft. And the index of that series shall be the tickers. So we can run this, then I can take a look at the weights. This is what I have here. And now we're going to just load the pricing data for all of these assets. So I'm going to say here prices is equal to none. Then I'm going to say for T in tickers, what I want to do is I want to say Yahoo Finance dot ticker T, then history max, and I want to get the close price. Maybe let me do it like this. I'm not sure if this makes a difference, but I'm going to do close, and then I'm going to rename the close price because I don't want to have it as close, because then we're going to have duplicate names. I want to actually rename it to the ticker. So that is going to be the ticker, which is going to be the price history. Let's call this H. And now what we need to do is we need to say prices is going to be H if prices is none. Else we're just going to join. So we're going to say prices join H how inner. That's the idea. And of course we need to say rename columns is equal to that. Once this is done, we get here 40 individual stocks, the closing price for every date. That is now aligned, and it's also already joined in a way that we get the earliest possible day where all of these three assets are already on the stock market, so already public. And now I can use that instead of just using a single asset, but I have to, of course, aggregate this because I still need a list of returns. So I need to accumulate the returns and then I need to add them together. So we can say asset returns is going to be equal to prices percentage change over time. I want to drop the NAs, and then the returns are equal to asset ret.mul. We're going to multiply them with the weights so that we have this proportional calculation here. And then I'm going to sum on axis 1, so column wise. And if we take a look now at the returns, we can see that we get the returns for the overall portfolio. Now then we can go up and do the same thing that we did before with the S&P 500 benchmark. So just go and say bench returns. Actually, we can keep bench returns as it is. So maybe let's just copy bench close percentage change. I'm going to just add this down below here. And then what we also want to do is we want to get the combination here. We want to join them. And I'm going to say down here, returns is equal to the entire thing here as before. Returns now is still the same. And what we're going to do now is just the exact same thing as before on this new data. So I can just copy the command that we ran. This here, I can go down and I can now see how this portfolio with these three assets would have performed against the S&P 500. And there you go. We can see that I have a crazy cumulative return here. This is 56,000% because of NVIDIA mostly, I guess. And you can see it's also unreasonable. It's unplausible. Actually, it's unexpected because we go outside of this funnel, you could say here. And also the drawdown periods, I mean, we do have them. They're quite insignificant compared to the volatility that we get here. This is very, very much AI driven, I guess. But that is how you can model and evaluate your entire portfolio. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, in case you're interested in freelancing services or tutoring, on my website you will find a services tab and a tutoring tab. There you can contact me for helping you with a project, teaching you something, providing freelancing services or something like that. You can contact me via LinkedIn or mail. You will find the links on the pages down below. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single feature video for free. Other than that, thank you much for watching. See you in the next video and bye.